Come on, we'll start with the next topic, that is the free fall. Now what is the free fall? Any body is thrown into the earth gravity, we say it is a free fall. Fine. A freely falling body or an object upon which only the force of influence is gravity. Fine. So if I say that, suppose this is a ball, when it is thrown, fine, from the, suppose we are standing on the first floor, fine, from the first floor, and you are throwing the ball, fine, downward, means towards the ground, we say this is a free fall. Fine. And here we know that for during the free fall, fine, the air resistance has a negligible effect. Definitely, otherwise the air resistance or the friction is there, but for the free falling body, air resistance has a negligible effect. So when any body, when released near the surface of the earth, it get accelerated downward, right, under the influence of what? Force of gravity. Fine. Now if I say that, suppose I throw the body in the downward direction, fine. When you throw the body in the downward direction, we know that the initial velocity is 0. Fine. You have to just throw it, fine, without applying the initial velocity. So due to the gravity, it comes down. Fine. When it comes down, it get accelerated. It get accelerated, or you can say its acceleration increases. Fine. And this is the ground level, you say. Now when you throw any body in the upward direction, means you are throwing the body against gravity. Gravity is always in the downward direction. When any body is thrown in the downward direction, we take G as positive. And when you throw any body in the upward direction, definitely some finite velocity has to be provided, finite initial velocity, and you are throwing the body against gravity, so we say it get decelerated, or its acceleration decreases. Its acceleration decreases. But how much decreases? We will see this. Fine. We know that acceleration due to gravity is generally 9.8 meter per second square. On the calculation point of view, suppose I take 10 meter per second square. Fine. Now suppose if I throw any body from the first floor. Fine. Now we know that its initial velocity is 0. Fine. But when it travels 1 second, we say, fine, in 1 second its velocity, what the value of G says, what? G is 10 meter per second square. It means that, what is G? G is ultimately velocity upon time. So that is 10 meter per second upon second. It means that when it move 1 second in the downward direction, its velocity increases by 10 meter per second. Fine. In the next second, means suppose it is 2 seconds. So in 2 seconds, its velocity is increased by 2 into 10 meter per second, that is 20 meter per second. Fine. So one second, during one second time interval, its velocity is increases by 10 meter per second. Fine. Similarly, when we throw any body in the upward direction, fine, we are providing, suppose initial velocity, I say 50 meter per second. Fine. Now you know that its acceleration, it get decelerate, you can say, or its acceleration decreases, we say, and it decreases by what? 10 meter per second square, I say. Fine. 10 meter per second square means what? Its velocity is decreases by 10 meter per second in 1 second. Fine. So when it travels 1 second, its velocity now becomes 40 meter per second. If I have thrown it by 50 meter per second, in the next 1 second, it becomes 30 meter per second. In the another next 1 second, it becomes 20. Next 1 second, it becomes 10 meter per second. Now when it reaches to the maximum height, when its velocity becomes 0, at that time it will come down again. Fine. So this is said to be the maximum height. Fine. And when it is thrown upward, its velocity goes on decreasing, and when it is thrown downward, its velocity goes on increasing. Fine. So these are the points of the free fall. You must understand that during the free fall, body is under the influence of only gravity, air resistance is negligible, or you can say it has the negligible effect of the air resistance. Fine. And when it is thrown upward, fine, its acceleration decreases, or you can say when it is released, Fine. In the downward direction, its acceleration increases. Why its acceleration increases? Because body is thrown in the direction of gravity, and when it is thrown upward, you are throwing the body in the direction opposite to the direction of gravity. Fine. Now you must remember few points regarding the free fall. When body is thrown upward, fine, some initial finite velocity has to be provided. Fine. G value is taken as negative, and when your body is thrown downward, fine, G value is positive because you are throwing the body in the direction of gravity, and initial velocity is 0. Fine. Now we see the equation of the motion of constant acceleration. Fine. This can be replaced, fine, when the body is thrown upward in free fall, and when the body is thrown downward in the free fall, what changes must be there? Fine. When it is thrown, we say upward. Fine. So we have to give some initial finite velocity, and acceleration is replaced by minus g here because throwing against gravity, and s is replaced by h. And at the maximum height, we know that its velocity becomes 0. So this equation, first equation, v is equal to u plus at, final velocity when I take at the maximum height 0, initial velocity has to be provided. So it is, suppose finite velocity is u, a is replaced as minus g, fine, because thrown against gravity, and t is a time. So from this equation, we can find out what is the time to reach at maximum height using the formula u by g. Now the second equation, that is v square minus u square is equal to 2as. Final velocity when reached at the maximum height is 0, we know. U square, that is a finite velocity which has to be provided. A is replaced as minus g, and s is replaced as h. Fine. So negative sign you can see cancels out. So u square becomes 2gh. So h is equal to u square by 2g. Fine. So this formula can be used to find out the maximum height when any body is thrown upward. Fine. Then the third equation of motion in a free fall becomes when a body is thrown upward. Fine. So s is replaced as h, u is a finite, that is ut, and a is replaced as minus g. So third equation becomes like this for a body when thrown upward. And for the downward, you know that when any body is thrown downward, initial velocity is 0. Fine. And a is replaced as plus g because you are throwing the body in the direction of gravity, and s is replaced as h. So first equation becomes like this: v is equal to, u is taken as 0, a is replaced as g, so v becomes gt. And what is this? This is the velocity which is gained by the any object when it is thrown downward in time t. So v square minus u square is equal to 2as becomes like this: v square minus 0 square is equal to 2gh. A is replaced by g, s is replaced by h. So this is a way also where the height is given to us, we can find the final velocity. S is equal to ut plus half at square. Fine. So s is replaced as h, u is 0. Fine. Half at square, so now becomes half gt square. So height becomes half gt square when any body is thrown downward. I hope you understand this.